The first transformation that we'll focus on is when we see a change in amplitude from the parent function. So in this case, in the position of A in our equation, we see that there's a 2 instead of just a 1 or nothing written there. So that means that our amplitude is going to be 2, meaning that our graph is going to not max out and bottom out at 1 and -1 like the parent graph, but instead all of our outputs are going to be doubled. So we're instead going to bounce off of 2 and -2. So we're increasing the amplitude. We're increasing the height of the highs and the low of the lows. But everything else about this function is going to stay the same. So the period is still going to be 2 pi. There's no vertical translation, and there's no phase shift. There's no horizontal translation. So the first thing we have to do is we have to label out our coordinate axes. And so our technique is to take whatever the period is, which is unchanged from the standard 2 pi, and go out to the 4th tick mark and label that as 2 pi. Halfway then, 2 tick marks would be pi, which means each tick mark is half of that, which is pi over 2. Then I can label up 3 pi over 2 in the middle here, and then I can extend out. So this will be 5 pi over 2, and then 3 pi, and then 7 pi over 2, and then finally 4 pi. So this sets me up to be able to plot 2 full periods. Along the y-axis, I can go ahead and just count by ones, since because of my amplitude, I know I'm going to be going up 2 and down 2 from the x-axis. So counting by ones is reasonable. So I'll go 1, 2, 3, 4, 5 going up, and then the same thing going down. And now we're going to take that parent graph of sine and just change it so that the high points are at 2 and the low points are at -2, instead of the high points being at 1 and the low points being at -1. And so sine starts its cycle at 0, so it starts at the origin. It ends its cycle 2 pi away at 0. If we look back at the parent graph, halfway through the cycle, it's at 0, so that's going to be at pi. And now, halfway in between the zeros, it's either at a maximum, which now is going to be up at 2, or it's going to be at a minimum down here at -2. And so that is enough for me to be able to sketch 1 full period. And so then we'll extend that by sketching a second full period by just repeating the exact same thing. Since these are periodic functions, they just repeat themselves. So I count over 1, 2, 3, 4, over here to 4 pi. That's 2 pi away from the end of the previous cycle. Halfway in between, we're going to be at 0. And then halfway in between the first 2 zeros, we're at a maximum, which again is at 2, thanks to the amplitude change. And then we're at a minimum of -2 in between the second and third zeros, thanks to that amplitude change. And so then we have the sketch of our graph. For the next example, we see that we've got an 8 out in front of the cosine. So we're going to be working off of the parent graph for cosine, but now our amplitude is 8, meaning that the high points and the low points of the graph are not going to be at 1 and -1, but they're going to be at 8 and -8. But everything else is going to remain unchanged since we don't see any other constants introduced into our equation. So our period is still going to be 2 pi. We're not going to experience any vertical translation nor any phase shift. So once again, I'm going to label out my x-axis the same way, go out to the 4th tick mark, and we use whatever the period is as that label. This makes it so that all of our high points and low points and zeros will end up at these tick marks. So then that makes the middle here pi. Then we've got pi over 2 for each tick mark. So that puts this at 3 pi over 2, then 5 pi over 2, 3 pi, 7 pi over 2, and then finally 4 pi. So this sets us up to be able to graph 2 full periods. Now our amplitude this time is 8. Well, I only have 5 tick marks in the y direction, so I'm going to have to scale this not by counting by 1s, but we could count by 2s. And so we just need to make sure that we label our axes so that we can see what we're counting by, but we're not restricted to counting by 1s every single time. So -2, -4, -6, -8, and then -10 down here on the bottom. And so now we're ready to go ahead and sketch our graph. Now cosine, if we go back to the parent graph, doesn't start at 0 like sine does. It starts at a maximum. So instead of starting at 1, which is what the parent graph does, we're going to start at 8. So I'm going to start off with a point up here at 8 on the y-axis instead of at 1. Now, cosine starts at the top, so it ends at the top. And that's going to be a period away, so that's going to be at 2 pi. So I'm going to put a dot there. Halfway through the cycle, cosine is at a minimum, so that's going to be at pi. We're going to be down here at -8 because of that amplitude of 8. And then halfway in between the maximum and minimum points, the graph is at 0. So that's going to happen at the over 2's, pi over 2 and 3 pi over 2. So with that, I can go ahead and sketch one period of this cosine function that has an amplitude of 8. And then I'm going to repeat the same thing to sketch a second period. So again, I'm going to go 2 pi away since that's my period. So 2 pi plus 2 pi gets me to 4 pi. So that's why I max out there. Halfway in between at 3 pi, we're going to be at a minimum. So that's going to be at -8. And then halfway in between the maximum and minimum points, cosine is at a 0. And so that gives us the framework to be able to sketch the second period of our graph. For the last one, the big difference that we see here is we have a -3 in the position of that amplitude variable constant instead of a positive. We're still going to say that our amplitude is 3. Amplitude is defined as always being a positive value. It's measuring the distance from the 0 line, the x-axis, to the high points and to the low points. And so since it's a distance, and then in this context, it'll be declared as positive. Everything else is the same, 2 pi, 0 and 0 for the vertical and translation and phase shift. So the impact of that negative sign means that we're going to have a reflection. So instead of the graph starting at 0 like it does for sine and going up, it's going to start at 0 and go down. So we'll see that in just a minute. So if I scroll down a little bit and start labeling up my x-axis, same way as we have the others. So 2 pi is the fourth tick mark, makes pi the second tick mark. Half of that is pi over 2, so that puts us right here. So then we've got 3 pi over 2 in the middle there, 5 pi over 2, 3 pi, 7 pi over 2, and then 4 pi. So that sets us up for our 2 full periods. Since 3 is my high and low point, I can go ahead and count by 1s again along my y-axis. 4 and 5, -1, -2, -3, 4 and 5. And so then once again, sine starts with a 0. It starts at the origin, so that's going to be my first point. It's going to end at a 0, so that's 2 pi away. I'm going to put in a 0 there. Halfway in between, it also is at 0, so that's at pi. But now, normally sine goes up first from the starting point of the cycle and then drops down. But because of the negative that we have in front here, it's going to be reversed. It's going to be reflected. So now instead of going up, it's going to go down, but it's not going to bottom out at -1. It's going to bottom out at -3 because of our amplitude of 3. So halfway in between the first two zeros, I'm going to be down here at -3. Halfway in between the second and third zeros, I'm going to be up here at +3. So there's the first period of my graph. And now I'm going to repeat that one more time. Go out 4 tick marks, 1, 2, 3, 4. That's going to be the end of the next cycle. Halfway in between, it's at a 0. And then again, because of the negative amplitude, it's going down first instead of up. So we're going to bottom out here at -3 at 5 pi over 2. And we're going to top out at 3 at 7 pi over 2. And so now we can go ahead and sketch in the rest of our graph.